A curve has the equation y equals g of x. Given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x, the curve with the equation y is g of x passes through the origin. The curve with equation y equals g of x has a stationary point at 2, 9. Find g of x. Prove that the stationary point at 2, 9 is a maximum. So g of x is a cubic graph, so we can write it as ax cubed plus bx squared. Now we've been told that the coefficient of x cubed is the same as coefficient of x, so we could have plus ax, and because it passes through the origin, even though we could have plus c here, this is 0, so c is 0, so we don't need to put that part there. Now the curve has a stationary point at 2, 9. So if I was going to do just a rough sketch of the curve, it's a cubic graph, and we would have a 2 turning point usually. So we could have something like that. Now we know that the stationary point is 2, 9. So it means that when x equals to 2, g of x is 9. So we can substitute that values in. So a 2 cubed minus or plus b 2 squared plus a 2 is 9. So we would have 8a plus 4b plus 2a equals to 9. We can simplify all that, so we have 10a plus 4b equals to 9. So that's one of our equations. The next one is the fact that it has a stationary point at 2, 9. So that means if this is g of x, we're going to do the derivative of g of x at 2, and that would give us 0. So we're going to do the derivative of our g of x with the unknown letters. So we're going to write another equation. So g of x is ax cubed plus bx squared plus ax. We're going to find a derivative of that. So we're going to do 3a x squared plus 2bx plus a. That would be 0 because the derivative would be 0 because of the stationary point. We're then going to substitute 2 into that equation. So we would have 3a2 squared plus 2b times 2 plus a is 0, because at that point the gradient is 0. So we would have 12a plus 4b plus a is 0. We can simplify that to 13a plus 4b is 0. So now we've got two equations. So this is equation 2 and this is equation 1. So we're going to use that to help us find the value of A and the value of B. So we have 13a plus 4b is 0. We have 10a plus 4b is 9. Going to subtract that. So we have 3a equals minus 9. So a is minus 3. Now that we know a is minus 3, we're going to then use that to help us find letter B. So we could potentially just use any of the equation 1 or 2 to work that out. So 10a, so minus 3 plus 4b is equals to 9. So minus 30 plus 4b is 9. 4b is 39. So 4b is 39. So it means that b is 39 over 4. So now we've got our a and b values. We can then put that back into the original equation. So the original equation we had was g of x was ax cubed plus bx squared plus ax. So a is minus 3, so we can put that into the function. So minus 3x cubed plus 39 over 4x squared minus 3x. So that would be the equation of the curve. So that's g of x. Right, we then need to prove that the stationary point, let's just have a look at the question, is the minimum. So part B, prove that the stationary point is the maximum, actually not the minimum. So we're going to do the second derivative of g of x. And if the second derivative of g of x is negative, it means that it is the maximum. So let's do it on this side. So the equation of the curve was g of x is 3x cubed plus, actually it's a minus 3x cubed plus 39 over 4x squared minus 3x. The first derivative of this equation, of this curve, is going to be minus 9x squared plus 78 over 4x minus 3. The second derivative is going to be minus 18x plus 78 over 4, which is the same as 39 over 2. So if we simplify it straight away. Now when x is 2, we need to find out what the value is. So when x is 2, we'll have minus 18 times 2 plus 39 over 2. Now that's going to be a negative value. We would have a negative minus 33 over 2. Because that's a negative value, it means that it is a maximum point. So we can then conclude that when x is 2, we have a negative value, so it's less than 0. Therefore, it is a maximum point. All right, thank you for listening. Bye now.